This is Chapter 2, Copper Core Cable. Electronic signals are classified into two general types, analog and digital. Analog signals vary in intensity, like a wave, while digital signals have discrete values, like zeros and ones, plus or minus 5 volts. An electronic signal can be measured by its frequency. Frequency is the number of cycles of an electronic signal that occur in 1 second, and it is measured in hertz, or megahertz, or gigahertz. Electronic signals degenerate or lose amplitude over long distances. This losing of signal strength is known as attenuation. In addition to attenuation, most electronic signals pick up interference from other sources, such as motors, fluorescent lights, transformers, and radio transmitters. This is electromagnetic interference, EMI. The interference is an undesired electromagnetic signal imposed on a desired electromagnetic signal that distorts or corrupts the desired signal. It is sometimes referred to as noise, especially, say, on the radio. Interference that comes from neighboring conductors in the same wire's jacket is called crosstalk. Latency is basically a measurement of the amount of time it takes a signal to travel from source to destination. A general cause of latency is simply network equipment along the path. There is generally a maximum amount of time a packet is allowed to circulate through a network before it is dropped or destroyed. This is referred to as time to live. The overall latency is too great, or if the overall latency is too great, the packet could be dropped from the network before it reaches its destination. Bandwidth is a measurement of the network media's ability to carry data. The definition of bandwidth varies according to the context to which it's applied. Network bandwidth is measured in bits per second, or sometimes megabits per second. There's a difference between baseband and broadband, if you hear those two bandied about. Baseband is basically one signal taking up the entire bandwidth, or just one signal using the entire bandwidth, whereas broadband puts many signals on the same bandwidth. There's also types of communication. Simplex simply means one-way communication. It just goes one direction. Half duplex is bidirectional, but it only goes one direction at a time. When I was on satellite internet, it just went one direction at a time. And full duplex is true bidirectional. It goes both directions simultaneously. Networks that incorporate copper cable have limits to the type of cable, the length of the cable, and the number of segments that can be in the cable. To understand why, we have to understand some basic terms. Resistance is one of those terms. It's the opposition to direct current. Every conductor has a certain amount of resistance that affects current. The longer the distance, the greater the resistance. You also have reflected loss. In high-speed networks, data flows in both directions at the same time, such that when a signal reaches its destination, some of it is reflected back the way it came. If this is large enough, this reflected loss can disrupt communication. Crosstalk is a type of interference that occurs when one pair of conductors imposes a signal on another pair of parallel conductors. Magnetic induction is the electronic phenomenon that a current in one wire can create a current in another wire in close proximity. Crosstalk originated as a phrase in telephone communications because when telephone wires crosstalk, it actually replicated the conversation from one pair of cables to another pair. So you could hear someone talking on another pair. XT, or next, is near end crosstalk, the X being cross. It's a measurement of the reflected loss at the input end of the cable. Losses are typically measured in decibels. FEXT, or FEXT, is far end crosstalk. It is a measurement of reflected loss at the output end of the cable. It is also expressed in decibels. Equal level far end crosstalk, or ELF-EXT, is a measurement calculated by subtracting the effects of attenuation from the FEXT. ELF-EXT negates much of the attenuation by raising the attenuated signal by a value equal to the attenuation. This would bring the attenuated signal, in other words, the weakened signal, back to the desired level. This is what the term ELF-EXT implies by equal level. It equalizes the loss with a gain. And alien crosstalk, AXT, is a measurement of noise introduced outside the cable jacket, typically caused by other network cables in close proximity or that are bundled together with your cable. Cables that carry high-frequency signals are susceptible to alien crosstalk, but at lower frequencies, alien crosstalk is not much of a problem. So the faster we communicate, the more alien crosstalk is a problem. Core cables are commonly constructed with a center core of copper surrounded by an insulating jacket. All copper core cables have an American wire gauge rating based on diameter. The smaller the number, the larger the wire. Therefore, gauge 0 is huge, whereas gauge 22, 24, 26 is fairly small. The smaller the number, the larger the wire. You also have something called plenum ratings or plenum rated cables that have a special type of exterior insulation that will not give off toxic gases when it's burned. And just so you know, plenum actually means crawl space. It is the area above a drop ceiling or below a raised floor that we oftentimes run cables in. If you're going to run a cable in a plenum, it must be plenum rated. Here, let's talk about several types of copper cable. Coaxial cable, or simply coax, consists of a copper core conductor surrounded by an insulator, which is also referred to as a dielectric. The dielectric is covered usually with two shields, a foil shield and a braided copper shield. The shields protect the core from electromagnetic interference. The shields also prevent the cable from transmitting EMI to other cables. And then the entire cable assembly is covered by an insulating outer jacket which protects the shielding. Twisted pair is another copper core cable that is much used. Twisted pair consists of 4 pairs of twisted conductors, which means it equals 8 wires altogether. Twisted pair is the most common choice for network cable. The wire gauge sizes range from 18 to 26, but usually the wire size in twisted pair is 24. When we're talking network cabling, there's possibly 4. There's 3 types of wire we deal with all the time. Cat 5, Cat 5E, I believe the E stands for extended, and Cat 6. There are actually 7 categories of twisted pair, Cat 1 through Cat 7, but we mostly deal with 5, 5E, and 6. There's UTP cable, which is unshielded twisted pair, and STP, which is shielded twisted pair. Basically, Category 5 can handle rates of speed up to 100 megabits per second on 2 pair or 1,000 megabits per second on 4 pair. Cat 5E supports higher data rates easier. And Category 6 can handle rates of up to 1 gigabits per second. If you'll notice between those 3 wire types on your screen, you'll notice the twists from Cat 5 to Cat 5E. Cat 5E has more twists per inch, and Cat 6 has many more twists per inch. That definitely makes a difference. talk about classification. 10 base T classification specifies the use of category 3, 4, and 5. Hopefully you'll never see anything less than Cat 5. Unshielded twisted pair cable. It is arranged in a star topology, normally, follows the 100-meter rule. The 100-meter rule means you can never have a run of a line longer than 100 meters, or 300 yards, basically. If you keep it under 300 yards or 100 meters, the signal strength will be sufficient when it reaches its final destination. You can use a repeater of some kind to extend the distance an additional 100 meters or 300 yards. In 1998, the IEEE standards approved 100 base T, which is also known as fast Ethernet. The fast Ethernet classification differs in the mode of communication and the number of twisted pairs that they use. Fast Ethernet works over most existing Cat 5, 5E, and 6 cable. There's still a 100-meter limit or 300-yard limit. A year later, in 1999, 1,000 base T, which is also called gigabit Ethernet, was adopted. Higher speeds were accomplished by using cable that supported higher data rates and using all 4 of the cable pairs instead of just 2 to allow for full duplex transmission. It's important to note, however, that with fast Ethernet and gigabit Ethernet, not only must the cable be able to support the higher data rates, but the network hardware, such as your NICs, your Ethernet cards, your switches, your routers, all have to support the higher data rate. Most Ethernet cables, if they're just the patch cables, have RJ45s on the end. RJ45 connectors are for twisted pair. You notice there on the diagram there's 8 wires coming into that RJ45. When installing an RJ45 connector, it's important that the conductors be inserted into the appropriate pins. 2 standard connections are recognized by the industry, 568A and 568B. We're mostly going to be working with straight-through cables that are based on 568B on both ends. To install an RJ45 connector on an unshielded twisted pair cable, you have to first strip the insulating jacket from a portion of the cable to expose the conductor pairs. The pairs then untwisted in that area that's exposed so that each conductor can be inserted into one of the designated pin areas. When the RJ45 connector is crimped, each conductor then makes contact with one of the 8 pins. So let's talk about power over Ethernet. If I have a remote device such as, I don't know, wireless access point in my attic or ceiling, a webcam or IP cam out somewhere, which doesn't have a standard 110 plug somewhere near it. Power over Ethernet standard 802.3AF specifies the supply of small amounts of electrical power to network devices like cameras, IP phones, wireless access points, and even speakers. The amount of power delivered is approximately 13 watts at 48 volts, and the cable used for power over Ethernet must be rated category 5 or better. 2 pair of the cables inside the cable that are used for network communication, and 1 pair is used to supply the electrical power. So, as you see in the diagram, with non-power over Ethernet, you have to have the red plug there, the red cable that just plugs in a wall. With power over a switch or injector, the switch or the injector plugs in the wall, and the power goes across the Ethernet cable to the device. And with power over a NIC card, which I rarely see, the power actually just comes straight out of the NIC card to the device. When we're making cable, there's some things that can happen to cause the cable to be bad. A short would occur when 2 conductors are improperly connected, which results in a short circuit path. In other words, maybe there's a tear in the coating and the 2 coppers meet somewhere in the middle. That's going to cause a short circuit. An open would indicate that the circuit has an open spot along the length of the conductor. Maybe one of the wires inside has been cut, or maybe you didn't crimp it properly so that it doesn't make connection on the far end. A ground typically occurs where the conductor's insulating jacket is torn and the copper conductor is making contact with some other metal surface that is grounded. And also, you can reverse the wires, you can cross the wires, you can split pairs, and that commonly occurs when technicians install connectors on the RJ45 connectors on twisted pair cables in the field, possibly in the dark, in attics, in the heat. It's very easy to misconnect individual wires on an RJ45 connector or when you're punching it down into a block of some kind. Always remember, keep calm and document everything.